Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. So today we are going to go over the second part of the June 2023 Regents Exam for Algebra 1. We start with problem 25 since we did the multiple choice, which were 24 problems. These are 8 questions and each one is worth 2 points, but now you have to show your work. It's not just selecting the correct answer. So the first question says, solve the equation algebraically for x. And this is very simple algebra. So we start by distributing the negative 2.4. So you multiply negative 2.4 times x, you get negative 2.4x. And then negative times positive is negative. You multiply 2.4 times 1.4. Use your calculator. Or if you know that 1.9, 169, you subtract 0.25, right? So 144, what? That doesn't make sense. 160, wait, what? What am I saying? 361 minus 0.25, right? So 136. How could it be 1? What am I doing? 336, I should say. 2.4 times 1.4, yeah, 336 equals 6.8x minus 2268. Since the positive x is on the right, maybe we move the x's to the right and the constants to the left. So for example, I can add 2.4x to both sides. And then if I want everything to the left, I'm going to add 2268 to both sides. So these cancel and those cancel. And you get 6.8 plus 2.9 is 9.2x equals, and then when you add these, you will get what? 2604. And finally, I'm going to divide both sides by 9.2. You are showing your work. And you can say x equals 2604 divided by 9.2 is 2.83. Did they? Okay, wait a second. Let's check what we did. Yeah, of course, I added these instead of subtracting. I'm sorry. 2268 minus 336 is 1932. And then you divide 1932 by 9.2, you get 2.1. So x is 2.1. Of course, you can go back and check. So you can say negative 2.4, you open the parentheses, you have an x, so you write 2.1, and you add 1.4, and you see, so the left-hand side is negative 8.4. The right-hand side is 6.8 times 2.1 minus 2268, and you get negative 8.4, so you checked your answer. You can write the check here, by the way. Okay, the function f of x is graphed on the set of x's below. State the zeros of f of x. Of course, you have a 0, so this x equals, and the set of the values are negative 2, positive 2, positive 3. Explain your reasoning. Well, the zeros of f of x is where the function crosses the x-axis, right? And f of x equals 0. So, or we can call it the solution of x, or we can call it the x-intercepts of the graph. So all of these are fine, and these are the 3 values that we have. So that's basically reading off the graph. It's very easy. The third question said, Brianna creates the pattern of blocks below in her art class. A friend tells her that the number of blocks in the pattern is increasing exponentially. Is her friend correct? So we can count the number of blocks here. We have 4, and then we added 1 and 2, so they become 6. We added 1 and 2, so they become 8. We added one, so we add horizontally and vertically, so that's definitely not an exponential, that's an arithmetic sequence, so to speak. No, her friend is not. Oops. Many times is not correct. Explain. Well, the increments are constant, so the pattern is increasing linearly, not exponentially. Right? If it's exponentially, it would be a multiple. So for example, if that's 4, it becomes 6, then it increased by 1.5, so you multiply by 1.5. Or if it's like 4, 8, 16, 32, it would be by a multiple of 2. Okay, again, just counting, you would know that. The data set 20, 36, 52, whatever, represent the number of books purchased in 9 book club members in a year. So there are 9 values. Construct a box plot for these data on the number below. So first of all, to construct a box plot, you need the minimum, the first quartile, the median or second quartile, you need the third quartile, and you need the maximum. So it's better to rearrange them in an increasing order. So the only single digit is 4. Then in the tens, I have only 16. In the 20s, I have a 20, then 24. So it's a good idea to cross out what you wrote, right? So we have the 20, then I have 24 and 28. So 24, 28. In the 30s, I have 36. In the 40s, I have 40. And in the 50s, I have 52, 56. I count them, they are 9, so it's correct. And because they are 9 data points, then you say 9 plus 1 over 2 is 10 over 2 or 5. So you count 1, 2, 3, 4, 5. That's the median right there. And now you have 4 below and 4 above. You take the 4 below and find it their median, which is the average of the second and third. 16 plus 20 over 2 is 18. And 1, 2, 3, 4. So between the second and the third, they are different. The difference is 12. So 46, 6 above the 40 and 6 below the 52 is the third quartile. So now I have the 4 is the minimum. And then my box goes from the first quartile, which is 18. 18 is somewhere between in the middle of these two values. So, and then in the middle at 46. So this is 44 and 48. 46 is in the middle. So this is my box. We call it sometimes, the box plot or box and whiskers plot, because these look like the whiskers. Oops. Well, we should do it better than that. The median is 28, which is here. And then the maximum is 56, which is there. In fact, we don't have outliers here. So these are the whiskers. So 4, that's the minimum. 18, that's Q1. 28, that's the median or Q2. 46 is the Q3. And oh my God, I'm sorry. Yeah, 56. Is it? No, 56 is here. That's the 60 for some reason. This is 56 or max. And of course, you draw by pencil, so you just, erase this piece. So that's the box plot. Okay, you can list the minimum, but we already showed them on the figure, so that should be enough. Alrighty, next. Express a squared plus b in standard form. Okay, a is x plus 5, so x squared, so a squared plus b equals, the a is x plus 5, I square that, and then I add b, which is x squared minus 18. You can expand that as x squared plus twice the first times the second, so it's 10x plus 25 plus another x squared minus 18. If you want it in standard form, like in a decreasing order of the power, meaning here that's a quadratic equation, x squared plus x squared is 2x squared. I only have, the x is only 10x. And then I have 25 minus 18 is positive 7, and that is a squared plus b. Pretty straightforward, nothing hard, right? The two relations shown below are not functions. This relation, why isn't it function? Yes, because if I say x is 4, I have two values for 4, 20 and 30. Explain how you could change each relation so that they each become a function. So I can say delete the x, the middle, like the middle horizontal line, or I can make one of these two, or make make one of the values at x equals 4 an open circle, an open hole, like, or open circle, if you call it, instead of closed. If I make that open, or if I make that open, then I have a function because I have a unique value of f of x or whatever of y for every single value of x in my domain. Okay, when I go to the second relation, -5, -4, -2. Okay, I have -4 and -4, and again, that makes it a relation. So for relation 2, so this is relation 1. For relation 2, either delete the point -4 and 0, or -4 and 4. You can delete one of them and it will become a function now, because for every single value of x, there is only one value of y. Now there are two, so it cannot be a function, right? Okay. Number 31. Factor 2x squared plus 16x minus 18 completely. First of all, I can factor a 2, and that would make it x squared plus 8x minus 9. You can use the quadratic equation, or you can factor, because you need two values that multiply to -9 and add to +8. So that's definitely +9 and -1. So it's so easy. You can say x plus 9 times x minus 1. So now 9 minus 1 is 8, and 9 times -1 is -9. And that's it. It doesn't take 5 seconds. If you want, you can say this is A, this is B, this is C, and you can say x equals, that will give you the answer for x. So you have to make it, or you can also complete the square. You have too many ways to do it. I don't think we need to do that. It's a waste of time. But since I already wrote it, -b is -16, plus or minus the square root of 16 squared, which is 256, minus 4 times 2 times that is plus 144, right? 8 times 18 is 144 over 4. So it's -16 plus or minus the square root of 400 over 4. So it's negative 4 plus or minus. This is if you take 16, it's 16 times 25. So if you take 16 out, it becomes 4. Divide by 4 is 1. So you get negative 4 plus or minus 5. So you can see the value of x. You have x plus x. So x equals negative 4 plus 5 or 1, or x equals negative 4 minus 5 is negative 9. So you know we have one factor is x minus 1 and the other is x plus 9. But notice because you simplified by 4 here, and you have to go back and say that when you multiply x by 9 times x plus 9 times x minus 1, the coefficient of x squared is 1, and here it's 2, so you have 2 outside. But definitely it's so easy to factor it or to complete the square. So if I want to complete the square, I would say 2 times, and like we mentioned before, you just do the x squared plus 8x, you leave a blank, and then you subtract the 9. Keep the 9 outside. And you say, in order to make that a complete square, I divide the 8 by 2, so it becomes 4, and then I square it, so I add 16. Notice I didn't add 16. No, I added 32. And that's a common mistake that students don't see when they complete the square. I have a 2 out. 2 times 16, that's what I added. I added 32 to the left-hand side. So I have to subtract 32. Okay? So we said this is 8x, and this is minus 18, right? Wait, what did I do? The original problem, I took 2 out, so that makes it x squared plus 8x minus 18, because the 9 is not inside the parentheses. I hope I didn't confuse you. I added 32, and I subtracted 32. So this becomes 2 times x plus 4 squared minus 40. No, 50. Why did I say 40? Okay. The 50, again, there is a 2 here. So if I take a 2 out, this becomes x plus 4 squared minus 25. If I include it in the parentheses, that can be written as x plus 4 squared minus 5 squared. So what's between the parentheses is a difference of 2 squares. So it's the first minus the second times the first plus the second. And you get 2 times x minus 1 times x plus 9 as before. But I think it's much easier just to factor it, okay? Using the function would be tough because you have to go back and check that the x multiplier is 2, not 1. And completing the square is taking more time than needed, really. It's very simple to just factor it. Okay, solve this algebraically for all values of d rounding to the nearest tenth. Okay, so here I will have to use the quadratic equation, because since they told me that, it means I cannot factor. So I have a equals 3, b equals negative 8, and c equals 3. So I would say x equals negative b, which is 8, plus or minus the square root of b squared, 64, minus 4ac. ac is 9 times 4 is 36, divided by 6, which is twice 8. So this is 8 plus or minus the square root of 28 over 6 equals 8 plus or minus 28 is 4 times 7, right? That 4, square root of 4 is 2. So 2 root 7 over 6. I can simplify that and say 4/3 plus or minus root 7 over 3, or 4 plus. So x equals 4 plus root 7 over 3, or x equals 4 minus root 7 over 3. And then I use my calculator. So 4 plus square root of 7 over 3 equals 2.2 for the nearest tenth, or x equals, I go back and instead of plus, I make it minus, and I get 0.5. Well, we can go back and check that we didn't do any error. So 3 times d squared minus 8 times d, plus 3, I got 0. -1 times 10 to the -9. If I select the second value, which is 0.45, but they want it to the nearest tenth, so I can say 3 times this value square minus 8 times this value plus 3. No, I did something wrong. 3 times that minus. Why did I said minus and I typed plus. Okay, that should be minus 8d. Yeah, and sure enough, I get 0. So I can write x equals 2.2, 0.5, and that would be my answer. And that really concludes the second part. I don't know if we should continue, or I think it's better to stop here, and we can do parts 3 and 4 tomorrow. These are the 8 problems. Let me see something. Okay, with those, I just want to say that, again, for this problem doesn't take any time if you just factor. You say, I need 2 numbers that multiply to -9 and add to 8, so that's definitely +9 and -1, and you can factor that right away. I may have confused you by going through the other 2 methods, but you really don't need them. It's just, we could have done that in 15 seconds. So all these problems were really pretty straightforward. I don't see anything complicated. This one is straightforward. This one, you have to understand that for every single value of x, there should be a unique value of y for the function to be correct. Linear, finding the zeros. I think it's just pretty straightforward. Anyway, I hope it was clear for you. If you have any questions or any comments, please let me know by dropping me a line in the comment section, and I will get back to you as soon as possible. Tomorrow we'll finish the remaining 5 problems in parts 3 and 4. And until then, I wish you all the best. Bye.